Good afternoon, and thank you so much for joining us. We're proud to present our next speaker, Nathan McKay with F5 Networks. Please give him a warm welcome.
All right. Good afternoon, folks. Thanks for joining us here. I know it's a little bit late in the day, but we're going to go ahead and get started. My name is Nathan McKay. I work with F5 Networks in our Security Solutions division. So today we're going to be talking a bit about how to enhance your application security strategy. So first, let's kind of talk about what application security is, baseline here, right? A lot of folks think that it's just managing vulnerabilities or building firewalls or building out infrastructure, but why are we doing this, right? Security geeks tend to kind of get in the weeds on this stuff and love the latest and greatest shiny things. But ultimately, if we're boiling it down, application security, it's business continuity, right? It's this ability to maintain and grow revenue, to identify industry threats, and to protect our assets and customers, right? That is why we're investing so much in all of these security solutions, and that's why it's so important that everybody is participating in the application security ecosystem. This is what we're after, maintaining our businesses and protecting our customers. So, with that said, we've talked to a bunch of customers out in the field, and we ask them all the time, hey, what are you guys doing about application security in the cloud? And a lot of them tell us, well, we're on AWS. We inherit all of this application security. We inherit this security posture. And to some degree, that's true. But it's not the whole story. So if we break a given application apart into its various component services, we've got things like our application services tier where our code runs, access tier, TLS, DNS, our network infrastructure. There's this line, right? And where this line is going to vary, right? Depending on your SLAs, what type of applications you've built, et cetera. But ultimately, there is a line somewhere where your responsibility for the application begins and the cloud provider's responsibility for the application security and infrastructure ends. So we need to kind of bear this in mind when we think about how our apps are built, how they're deployed. If you're not familiar with F5 Labs, F5 Labs is our threat intelligence and security research organization. They're completely vendor agnostic. They just publish threat intel and reports that tell you, what we're seeing out in the wild, what type of risks, what type of threat areas, maybe how to deal with them, but mostly it's just intel. So one of the reports that we published not too long ago was this one called Lessons Learned from a Decade of Data Breaches. And in this report, it's going over the research, our engineers looked at 433 cases of confirmed data breaches, right? And of those, 338 had, confirmed breach record quantities. So these were known cases. They'd been published. There'd been analysis done of them. We could see the confirmed attack vector and breach root cause, who it affected, what the costs were, what the threat actor profits were. And again, this is a free report. You can go ahead and download this off of F5 Labs right now. But when we broke it down, what they ultimately found was 53% of all of these breach cases, they could trace back to initial attacks on application services layer. So things like web servers, like code stacks like PHP and Java. And an additional 33% of those could be traced back to breaches in user and identity. So those could be things like credential stuffing related attacks or breaches of administrative credentials, losses of administrative credentials. So what this ultimately means is that 86% of successful data breaches, they originate in your area of responsibility in the cloud, right? So 86%, that's a pretty big number there. Looking at this another way, if we map this to AWS's shared responsibility model, if you guys are familiar with that, we can identify where those live in this model as well. So again, 86% of all of these breach records, confirmed breaches, can be mapped down to platform, applications, identity, and access management. Again, as we can see in this diagram, that is clearly within your area of responsibility. So you do inherit quite a lot of security from AWS and from the very fact that you have applications deployed in the cloud, but it's not the whole story, right? You do have quite a lot of stuff you have to address yourself. So I'll give you an example here. If you're familiar with the OWASP top 10, this is going to look really familiar. So one example risk area is injection. And that boiled down is that insufficiently sanitized or unescaped input data can ultimately inadvertently lead to unauthorized command execution, data exfiltration, data deletion, and SQL injection is the classic example of this, guys. If you're familiar, again, with OWASP Top 10, you'll have note that this is something that's been on that list for 15 years now, right? 15 years, guys, we've been talking about injection. It's the #1 risk area on the 2017 update to the OWASP Top 10. So why? Why are we still talking about this risk area when we've known about it and it's been dissected and talked about for so long, right? It's because it's tough. It's a difficult problem to deal with. Looking at another one, known vulnerabilities, using software with known vulnerabilities, right? This happens all the time. Take a look at this graph here, right? This is the total number of published CVEs year over year. You can see that that number is only increasing faster and faster and faster. So if you look at, there's a dip in 2016 there, so it kind of looks like, oh, we had a lower reported incidence in CVEs in 2016. In actuality, what happened there was a problem with the recording and reporting of vulnerabilities that were reported to MITRE. So it's not, we didn't see a dip in 2016. We saw a dip in the management and reporting of them. So as you can see, 2017, we hit almost 14,000 reported CVEs in that year alone. That's not aggregate. That is just in 2017. So really, what we can infer from this is anybody who's using software and third-party software stacks, things like open source components, et cetera, they're going to have this risk. They're going to inherit this risk. So great. We agree there's a problem. We agree it's no small problem. What do we do about it? Well, if we boil these issues down, I mean, let's kind of take a step back. Why are we talking about them? Why are we still seeing them? And again, it's because they're difficult and complex problems. Despite being well known, despite being well dissected and well reported on, they're pervasive. They're still huge problems today. They're tough. And building coverage into your applications for all of those 14,000 CVEs reported in 2017 alone, and for all of these unknown injection risk areas, it's expensive. And you don't just do this once, right? This isn't something that you tackle with a given release and it's handled. It's something you have to do over and over and over again with every app that you ship and with every version of that application that you ship. So this is expensive and time-consuming process. It impedes your ability to get your app out the door and into the marketplace and in the hands of your customers. And again, it can be tough to even find the expertise to deal with these types of problems. So the result here is that these common vulnerabilities we keep talking about, they're difficult to defend against, and they remain pervasive. That's why we're still talking about injection, and SQL injection especially, 20 years after it became popular. So what do we do about all this? Well, we keep hearing about WAF. WAF can block attacks before they reach your applications. It's secure, expedient, effective. It's all pretty rote. We've heard all of that, right? But what you might not have heard is that WAF technology can help you reduce your cloud costs. So let's take a look at it kind of at a simplification here, right? We know that we're going to get X amount of traffic, and autoscale is going to account for the dips and the peaks. But we have to size our apps to handle and account for all of the traffic we're going to receive. And on the face of it, all of those requests can look the same. But if we start doing some inspection, decrypting the traffic, looking at all of the requests, profiling them, we start to see that not all requests and not all users are the same. We've got to deal with things like bots and scanners and all of our regular customers. So We know we've got a lot of traffic. Some of it's good, some of it's bad. Well, what do we do about it? Ultimately, WAF can help us start filtering some of that stuff out. We can strip out things like the network floods, our denial of service attacks. We can start stripping out malformed requests. We can start stripping out scanners and bots and filtering that. We can remove known bad hosts, not talk to them, right? And we can start doing fun things with workflow enforcement if we know how a human and a customer should be navigating our site. We can start whittling that stuff down. And ultimately, what we see here is this delta, right? Originally, we were paying for an app that could handle all of these things in addition to our regular customers. That's money that we've spent. If we are now filtering it all out, we can shrink the size of the required footprint. This is especially important in the cloud when we're paying for, by request, by CPU cycle, by every megabyte of memory use, ingress, egress traffic. We're paying for all of this stuff. So if we're filtering all of this out, we can start shrinking our applications and saving our company's money. This is huge, especially if you're a security practitioner and you've been trying to sell your company on something like WAF technology or the security tools that you need. You can show legitimate and real ROI with these tools because it's there. So, but what about data analytics, business intelligence? We hear all the time that data is the new currency or data is the new oil, right? But questions for you guys: how accurate and relevant or valuable is your data? Are you basing your business intelligence on analysis patterns and of data from the traffic that you're monitoring and receiving? Are you able to identify what is noise and ephemeral, such as bots and scanners? Looking at this another way, tools like WAF can help inform your business intelligence programs. So looking at that model we took a peek at earlier, we're getting all of this stuff ingress. Some of it's good, some of it's bad, or dirty and clean, however you want to look at it. If we think about it in terms of like oil, we have to refine oil before it's useful as fuel. Data is exactly the same way. We need to refine it and get it to a state where it's actually usable, so you're not serving bots and scanners and all of this ephemeral stuff that you don't want. Again, real business value. Your business intelligence folks, your marketing folks, they're going to find genuine value in that refinement of your data. So how do we do this? Well, if we want to improve our application security quickly and easily, again, WAF is a really handy tool that out of the box can provide substantial security and real value. We know that application security, and especially web application security, can be complicated, but we've got some really awesome options to help you deal with that. So again, this is a tool that you can implement into applications to help offload the work that your dev teams and that your security teams are required to do in order to keep things up and running and get apps shipped and out the door. So how do we do this from a technical perspective? Well, first we start blocking known bad requests. We know we get a whole bunch of just unwanted automation. Everything from SQL injection attacks, command injection, cross-site scripting, known evasions and encoding attacks. This is all stuff that we have to deal with. WAF can take care of that pretty simply and easily. We also need to stop talking to bad bots. So that means that you have to be able to classify and filter the ingress traffic and know what's good and what's bad and who you should be communicating with and who it's not necessary to communicate with, right? So one of the key aspects here is this idea that you not only need to identify malicious bots, but you need to be able to identify good bots or wanted automation, right? People are using things like Siri and Alexa all the time, more and more. We know that there are good bots, so your technology has to be able to account for that. So, but ultimately, we know that these systems, these automations, are sending us malformed requests. There's friendly bot imposters, and plenty of them are used to enable malware, and which is going to cost you additional money if you're serving up malware from your cloud and your VPCs. So we need to defend against bots quite proactively. We need to stop talking to bad IPs. We know that there are certain networks and systems that are used exclusively for malicious purposes, and that just aren't our customers, right? These could be scanners, these could be botnets, they could be malware hosts, phishing sites. You could also do things like use geolocation to manage who you're communicating with. If you know all of your customers exist within a certain area typically, you can use that information to inform your security solutions and classify connections and clients based on risk. So again, a great option available to you. We can also hide details that nobody needs. Out of the box, most application stacks leak all manner of information. They tell everybody in the header values and in meta information what you're running. Whether it's Apache or IIS, whether it's PHP, Java, the entire stack, it just bleeds this information out because for whatever reason. But this information is used all of the time for people planning malware campaigns or doing analysis of a given target. In fact, if you're familiar with the Shodan search engine, that's a tool that people can query to find sites that have a known vulnerability or a known software version that now has a new zero-day vulnerability, or one of our 14,000 CVEs that got published in 2017, right? So WAF can help you do things like filter out those details from the responses when you return the traffic or the request back to the clients. Simple and easy to do, and something that's often overlooked. We can also mask sensitive data. A lot of applications will bleed a bunch of things like credit card numbers, account numbers, social security numbers, custom defined, and we can filter for custom defined fields, so we can hide PHI and all of this stuff. This is data loss prevention, folks, and it's not just for like file servers and NAS and all of that. There's all kinds of information that gets sent back. There's things that get included in comments in your HTML and your JavaScript and the source code that is sent back to customers that could also be filtered, that they just don't need. You're also going to want to be able to see the hostile traffic, get some analysis, analytics from it that you can use to plan your remediation measures. So you definitely need reporting. And finally, we can also defend against layer 7 denial of service. This is kind of an area that's growing quite a bit. So if we're familiar with more traditional DDoS, what a lot of people think of is just overwhelming a given target with a flood of either garbage traffic or open connection requests, et cetera. But we're seeing this huge uptick in denial of service that leverages and exploits the way that applications are built, that sends legitimate requests that cause them to behave in unwanted ways, that sends asynchronous requests that cause your application to expend 10 or 100 times more effort than the attacker did. So with L7 DOS protection, we can do things like track application performance continuously, track URLs for utilization and resource requirements, and heavy URL is the term that we see all the time. We can block bots and let your own users through. And again, this is something that's just kind of, we consider to be almost part and parcel for maintaining an online presence, is dealing with denial of service these days. So good news, advanced WAF technology is more accessible and affordable than ever before. It should be in the realm of really anybody who has a public-facing website. This should just be part of your toolkit, the things that you buy or procure to build applications with so that your developers don't have to do it. We've got plenty of flexible and expedient deployment options, everything from on-prem to the cloud, per application instance. There's really any type of application we should be able to defend. So yeah, defend apps of any size and any variety. Policies are reusable and portable. Again, same policy on-premise should translate to in the cloud. And again, we have dedicated teams of researchers doing all of this heavy lifting for you to offload that work effort from your teams. Obviously, we're going to have comprehensive OWASP Top 10 support, but it doesn't end there. We've got effective protection against threats beyond the top 10 and more advanced threats, such as like fraud and or intellectual property theft and denial of service. Those are things that traditional WAF technologies can't really account for. So again, if we're comparing traditional WAF with advanced WAF, you're going to get OWASP Top 10, you're going to get some SSL TLS inspection, you're going to get signatures. With advanced WAF, you're going to get all of that and more. You'll get malicious bot protection, you'll get protection against credential attacks, and you'll get protection for your APIs. So why choose F5? Well, obviously, we're an advanced technology partner. We've got the networking competency, the security competency, and we've also been a recognized leader by Forrester is the example we've used here. So competent partner is what you need here. We can deploy anywhere with consistent app services policies. Again, dedicated partner. We can deploy apps anywhere and help you lower your TCO while contributing real business value. I think that's one of the most important things here. So extend your security as your AWS network grows. And that's the time that I had. So thank you for participating. If you've got questions, we'll kind of stick around. Our booth is just right over here. Come stop by and see us. We're doing prezos. We've also got some folks back here that are handing out some reports. So I mentioned our F5 Labs report. Definitely grab one of those on your way out the door. Visit us at f5labs.com. Keep your security programs informed. Thank you. That's the time I had.